Students, welcome to s.mathguru classes. So our main discussion is eigenvalues and eigenvectors. Last class we solved two problems of 2 by 2 matrix. Now let us consider one problem for 3 by 3 matrix. So find the eigenvalues and eigenvectors of matrix A equal to 3 1 4 0 2 6 0 0 5. This one. Now solution. First we have to find the characteristic equation. The characteristic equation is determinant A minus lambda I equal to 0. So this implies 3 minus lambda 1 4 0 2 minus lambda 6 0 0 5 minus lambda. Just we subtract lambda from diagonals. These are the diagonal elements: 3 minus lambda, 2 minus lambda, 5 minus lambda. It was given in first video number 1. It was given why this we subtract this. So now we expand this. We expand in this way, in this way, in this way. If we expand in this way, this is these two are 0. We taking this 5 minus lambda. This short 5 minus lambda if we consider, then this will be cancelled, this will be cancelled. We get 3 minus lambda 0 1 2 minus lambda equal to 0. So this implies 5 minus lambda multiplying this 3 minus lambda 2 minus lambda minus 0, this equal to 0. 5 minus lambda 3 minus lambda 2 minus lambda equal to 0. So this implies 5 minus lambda equal to 0, 3 minus lambda equal to 0, 2 minus lambda equal to 0. So lambda equal to 5, lambda equal to 3, lambda equal to 2 we get. These are the values of lambda. These are eigenvalues. Now next our requirement, eigenvectors. Now we have to find A minus lambda I x equal to 0. A minus lambda I x equal to 0. A minus lambda I, we know this value. This is 3 minus lambda 1 4 0 2 minus lambda 6 0 0 5 minus lambda, 5 minus lambda, and x means we consider x y z, and 0 means 0 0 0. We write in this way. Now we multiplying this is 3 minus lambda into x, this into x, 1 into y, this is y, 4 into z equal to 0, and 0 0 x plus 2 minus lambda y plus 6z equal to 0, and 0 x plus 0 y plus 5 minus lambda z equal to 0. This whole we consider number 1. Just multiplying this into x, 1 into y, 4 into z equal to 0, 0 into 0, 0 into x, 2 minus lambda into y, 6 into z equal to 0, and 0 x, 0 y, 5 minus lambda z equal to 0. Now this is our equation we get. Now case 1, the values of lambda 2, 3, 5. Case 1 we consider. Let lambda equal to 2. So I putting lambda equal to 2 in equation number 1. Now 1 implies in 1, if we putting lambda 2, then 3 minus 2x plus y plus 4z equal to 0, 0x and 2 minus 2y plus 6z equal to 0, 0x, 0y, 5 minus 2z equal to 0. Or we get this is x plus y plus 4z equal to 0, 0x, 0y, 6z equal to 0, 0x, 0y and 3z equal to 0. So we get this one. This is number 2, 3, this is 4 we get. Now solving 2 and 3. Solving 2 and 3. We get 2 and 3. In cross multiplication method, first we consider x, then this is cancel, this into this into this, we get this. So this will be, first we write 1 0 4 6. Next y, then 4 6 1 0. Next z, this cancel, 1 0 1 0. X, then 1 0 4 6, then y, this is cancel, 4 6, this is 1 0. This one, when you consider this y means this cancel, 4 6 1 0, this is 1 0. And z means this one cancel, 1 0 1 0. Now we expand this, x by 6 minus 0, y by 0 minus 6, z by 0 minus 0. So x by 6, y by minus 6, z by 0, dividing by multiplying both sides by 6, x by 1, y by minus 1, z by 0. Therefore, we get this is, suppose this one k1, x equal to k1, y equal to minus k1, z equal to 0 k1. Therefore, the eigenvectors x1 equal to, this is k1, k2 and this is 0 k1, this is k1, 0 k1, and taking k1 is common, we get 1 minus 1 0. We get first eigenvector 1 minus 1 0. By putting lambda equal to 2, we get this eigenvector. This is the eigenvector. Next, putting lambda equal to 3, lambda equal to 5 also. In the same equation, we get different eigenvectors. Now we consider case 2. In case 2, let lambda equal to 3. Now 1 implies, equation number 1 we get 3 minus 3x y plus 4z equal to 0, 0x plus 2 minus 3y plus 6z equal to 0, 0x, 0y plus 5 minus 3z equal to 0. This implies 0x plus y plus 4z equal to 0, 0x minus y plus 6z equal to 0, 0x, 0y plus 2z equal to 0. This is number uh, 5, 6, 7. Now solving 5 and 6. Solving 5 and 6. We get solving 5 is first we taking x, then this is cancel 1 minus 1, 4, 6, y, then this is cancel 4, 6, 0, 0, z, then this one cancel 0, 0, 1 minus 1, 0, 0, 1 minus 1. Now we calculate this x by 6 plus 4, y by 0 minus 0, z by 0 minus 0. So x by 10, y by 0, z by 0. So this is dividing by 10, x by 1, y by 0, z by 0. This equal to k2. Say we get k2. So this implies x equal to k2, y equal to 0 k2 and z equal to 0 k2. Therefore, x2 equal to, this is xyz, and this one k2, 0 k2, 0 k2, and k2 is common, we get 1 0 0. We get this. This is the next eigenvector. We get second eigenvector. Next, case 3. Case 3, let lambda equal to 5. Lambda equal to 5 putting, so 2, 3, 5 we get. First putting 2, we get this is the eigenvectors, and next putting 3 we get this, and 5 putting. So in equation 1 implies, here we get 1, 3 minus 5 x plus y plus 4z equal to 0. Next 0x plus 2 minus 5y plus 6z equal to 0. Next, here putting 5, 0x, 0y, 5 minus 5z equal to 0. We get this one. Next, this one minus twice x plus y plus 4z equal to 0. 0x minus 3y plus 6z equal to 0, and 0x, 0y plus 0z equal to 0. This is number 8, 9, 10. Solving 8 and 9, we get taking x, then x cancel, then this will be 1 minus 3. Coefficient of y is 1, this is minus 3. Coefficient of z 4, this is 6. Y, then this cancel, 4, 6 minus 2, 0. And z, then this cancel, minus 2, 0, 1, minus 3. We get this one. So when you consider x, then this one cancel, 1 minus 3, 4, 6. We always taking x, y, z, x, this. X, y, z we get this. Then when you consider y, then z, x, 4, 6, minus 2, 0. Z, then z cancel, minus 2, 0, 1, minus 3. Now we calculate this, x by 6 plus 12, y by 0 plus 12, z by 6 minus 0. So this is x by 18, y by 12, z by 6. This implies dividing by 6, x by 3, y by 2 and z by 1. If we dividing by 6, then we get this is 3, 2, 1. And this one we consider k3. So x equal to 3k3, y equal to 2k3, z equal to 1k3. Therefore, x3 equal to xyz, this is 3k3, 2k3, 1k3, and k3 common, we get 3, 2, 1. This is the eigenvector. Therefore, finally we get the required eigenvalues are 2, 3, 5 and eigenvectors are, one is x1, this is k1, 1 minus 1 0, x2, this is 1 0 0, k2, 1 0 0, and x3, this is k3, 3 2 1. This is the complete solution of the given problem. This problem is very easy, very important, very interesting also. So I hope you are all getting clear this solution. So if you are getting clear this solution, then please share this video to other engineering friends also and BHC major also. Thank you.